Hello everyone, I hope you all are doing great, and today we will be discussing about the major problem when it comes when you have hundreds or thousands of the collection of a video and you need to find the specific moment out of it so that you don't need to traverse through the manual process of getting that exact moment and also reporting that to find the hidden insights and maybe asking a specific type of a query to find a specific timestamp that incident happened. So here we will be talking about various type of a video which are like body cam, dash cam, CCTV or insurance claim videos, and how one can build it with an ease by making use of TwelveLabs through AWS Bedrock and Nemotron retrieval by NVIDIA for the document retrieval. So let's have a look at the workflow architecture first, and then we'll see the demonstration and how one can just set up an whole application code base for their own use case or for building an application around finding the legal evidence across collection of videos across multimodalities. So let's have a look. So how it works. When the user comes and wanted to do a search query, maybe finding a specific color card where the investigation is happening, or maybe somewhere the fire incident happened or something like that. And it goes to the hybrid search. In the hybrid search, there are two modalities we are talking about. First, the document retrieval, and second is the video retrieval. For the document retrieval, the search document chunks by text. So whatever the text which has been provided here is being converted into the embedding with the help of Llama Nemotron embed VL1B. And here, with the similarity search happens at the location in the S3 vector where all the documents have already been indexed, so that you get retrieval of the very appropriate chunks which you have queried about. The second here is, which runs parallelly, is searching through videos. So here we have provided a text, or maybe we could have provided an image or an entity, and then the query which has been provided goes through the model to get created as an embedding, which is TwelveLabs.Marengo embed 30v1, and this is the TwelveLabs model which you can access via AWS Bedrock also, or you can also make it use via TwelveLabs SDK. And here it searches similarity in the video index, which consists of all the videos which are already been indexed here, and we get the result of both as an documents and the videos, and also the video at a clip level. When you open any specific video, what you can do is talk to a video about the incident, about to getting to understand about very specific moment, and you get to generate a response around it so that you don't need to actually traverse through the whole stuff. So here is the API which has been built is ask video, and here the endpoint hits, and then it just sends the prompt which you have provided, the query, directly to the Pegasus with a kind of a predefined prompt plus your user prompt, so that the predefined prompt helps you to get the response in a way you wanted with the timestamp and everything. So we'll go through how this prompt template is being configured in the application for this specific use case. The second thing is running the analysis for the specific video ID or the specific video which you have selected. And here, all the analysis has been run by the same model of Pegasus via the AWS Bedrock. And the first thing, let's just see the whole of this in a chunk mode. So first is the analysis, and for the analysis, we need to generate. That model needs to generate the title, summary, risk, categories, topic, and the starter transcript. And you see this all are the response which is being generated via the Pegasus. The second is the insights, and insights detect the people, faces, objects, and keyframes. And here you see the face which has been detected here, or the objects which has been detected with the timestamp, with the name, all been done via the Pegasus model. Plus, it finds the specific frames like it provides the specific timestamp where that happens, and the parsing and frame extraction is the external utility which has been applied here. The third is timeline showing where each detected face appears. So as soon as we got the face which has been detected across the video, we also need to find where the presence of that face is been there in the whole video. And here the Merengo helps us to get the exact places by comparing it to the video, that specific video level of that clips. And at the last, the most important is the transcript. And here we generate the full timestamp transcript here, which you can see this. So the whole of the analysis which you see is been done with the 4 different endpoints which have a different purpose. And we're gonna see the whole of how the prompt template and how the endpoint is being configured in a way. And so let's have a look at the overview of the application so that you have the better idea of the application. As I have already discussed that there are many problems like fragmented video evidence, or there are like lot of cost which goes for the manual review process, or the videos can't be searched via a keyword, and there are a lot of like critical evidence which gets missed. And what this compliance does is a lot of stuff to get the hidden insights which we have already seen. So here we are making use of like the Merengo embed, Pegasus analyze, semantic search, and face matching. So let's have a look at the code. So here you can just make use of the whole of documentation here. Also, if you want to understand about the endpoint, all the endpoint documentation with the interaction workflow can be found here. And let's jump to how the analysis template is being defined so that it works well. So here you can see the prompt / video analysis. And here for the specific part of the first part, which is like generating the topic, and other part is been defined here as category topics, medium, risk, so that we get to understand like what is the priority, what is the category, how it should be defined, so that we get the very concise and very well-defined response. Second is for the transcript. Transcript is just like how it should be there, what should be the format, and other stuff. And here about detecting an object, like how the object should be, what type of object needs to be detected, and what type of face needs to be detected, how the face needs to be there, so that we get to know about the specific and what are the rules. So you can see like there are a lot of details here to get it. Like you can have like very concise also, but if you need to have like a more precise response which actually follows your guidelines, so you just need to add it here. So next we will gonna see is how the demo works, and at the same time we'll also gonna see the code. So let's have a look at the demonstration, and then we'll have a look at the code base as how it is being configured. So here you can see you can just add like any of the image to search about it, or maybe an entity, and here you can choose the entity which is already been indexed, or you can just upload any image here. And as soon as you upload any image, it detects the face automatically, or you can do a manual selection of that face. But here the Resonate SSD model is being configured, which is specific for the face detection. And here is the existing entities which you can select for the search. There are suggestion, or you can just type here, but let's go for the suggestion as police officer applying handcuffs to a suspect. Let's see. So as soon as the query is been sent, as we have seen in the architecture before, it goes for the both parallel endpoints. First for the both together only for the document retrieval and for the video retrieval. And here we got the response. So here you see the woman expresses frustration over the lack and and she refuses to calm down and is handcuffed. So we get that it specifically gets the proper chunk from that document, and you can also go to the document and see what actually happened in that document. And you get to see all the photos and the transcript which is there in the documentation itself. Here it has been generated by the video itself. All the response here is actually the automated analysis response, but you can upload any other document also and it works for that well, and you see how fast it is. So Nemo retriever makes it a lot faster, and here you can see all the clips and the videos which are there. So if I just open this as video, here you can see that when I look at this, here it actually identifies the clip moment where it happened and all other clips and all in the timeline where it appears. You can get an more idea about, and all this analysis which you see is actually the ones which is been, all the responses which you see is actually the analyzed via the Pegasus itself. So you can do a lot of stuff from analysis. Or okay, let's also see if I wanted to ask from video, like, does this video show any policy violation? Something like this, like. So as soon as I provided this query, this goes to the Pegasus and we get the response here itself. And whatever the timestamp which we will get here, we can interact with the video here, which is on the left side. Here we see the video shows several potential policy violation related to child safety and driving under the influence. At 4:02, the woman is seen talking to someone outside her car. The woman appears distressed, is eventually arrested for DUI. So we can just directly go to what point it is actually referring to, and we can ask like anything here. So we can just continue the chat and actually get to know more about the video, and we have not even seen like kind of the whole video of this 26-minute, and we got to know so much information by just viewing it in just few seconds. The other functionality or feature here is you can just add any entity, and this would be just list of entities which you can make use of. And all these entities are also getting stored in an S3 bucket, and all their embedding has been created with the help of TwelveLabs Marengo. And here is the chat application, very specific to the chat application, so that you can switch to any of the video and can have a conversation around it. Maybe this query. So here we can see the video above, which is of 8 minutes. Here we see suspicious or non-complaint behavior is evident at several points. The driver is initially driving with no headlights on. The driver refuses multiple times to step out of the vehicle, makes a sudden move towards something under his seat, causing the officer to draw their weapons. So you get to see like the specific points here and all of the information, which makes it so easy to track on for reviewer process or for the evidence. So there are a lot of stuff which can be done here. Okay, so let's have a look at the code now. So here we have already seen the prompt of the video analysis. Then we have routes for the ask that we have seen, ask.py, documents.py is for the chunking, which has been done. Embed, this is for handling of the entities as entities from image. Here we see that detect and crop faces. So here ResNet 10 SSD detection is been done to get the face, and then the face base 64 is been made, and then the embed image actually makes the embedding of that face with the help of Marengo, and then it is been stored here. Index add, you see. So this is the process of how the entity is being stored, and entity have their entity ID. And this is in the entity page, as all the entities were listed, is being listed with the help of API list entities, which is just about getting the index records, and it just gets the ID, type, and the metadata. And the main of the file here is the search.py, so the search video index. So whenever search happens, it happens as a hybrid search. If it's a text based search, like if the text has been provided as a query, is one of the part or the one of the component of the hybrid search. When it is been triggered, then it just first gets all this of information of top K clips per video, which has been configured already in the application, which is like clips per video is like 5, or it could be a 20, and all this information. It first checks whether is it an entity search, so that it needs to get the entity embedding and other stuff, but no, let's say for now. And here how it works: index search, query embedding, then top K is equal to top K and all that, and type filter as video and metadata filter, and then it checks and gets the result here. And here, when if the is entity search is there, then clip above threshold has been used, where the query embedding has been sent, where it is actually the entity embedding, and entity clip minimum score, and clips per video visual only true. And so it's kind of a very similar way. And what we got at the end is the ID, score, metadata, stream URL, and the clips. Stream URL is the specific URL. So when the indexing happens, the video is first been uploaded to S3 bucket, and then the embedding of it takes that stream URL, which is there in the S3 bucket, and store it into the metadata of that video. So this is the searchability part specifically. And here is the how document index has been searched. So it's very, very simple. Like when the text query has been provided, you just embed query that, and then search docs, and which is just providing the query embedding and the top K as how many chunks you want. And yeah, it's done. So it's very simple here, as you have seen. And here now comes up how the hybrid search has been configured. So it makes use of the thread pool executor just to run both of these functionalities that we have discussed to run parallelly. And here you see like search document index and search video index that we have discussed till now. So here you see the thread pool executor has been applied here, so that both of the functionality has been sent parallelly. So the video future is where the search video index has been sent, and the doc future is specifically where the search document index has been sent a request, so that we get both of this response together here in with the help of one single endpoint, which is the hybrid. So this is how the whole of the searchability works, as we have seen. And next which comes up is the how the Pegasus has been applied. So Pegasus has just been configured here for the invocation, so that the runtime of the Bedrock runs, so that we get to use it with the ease. And here the analyze video has been configured, and here you see like the how it is been configured, so that the whenever the model ID is the one which I have already shown to you, which was there in the architecture itself, and that the payload which is needed to be provided to get the response of. So how it works, it's there in the videos.py. So here we see that for the transcript specifically, it makes use of the Pegasus analyze video. It just sends the S3 URI, and which is specifically the path of that video, which consists of like a video ID, and then the prompt of get transcript prompt, and the temperature as 0, so that it's very deterministic, and response schema as transcript schema, so that we get the response in a very structured manner as we want. So for the detection of objects and the faces, here you see that the Pegasus Analyze video has been called here again, but here the get detect prompt has been sent, and then the parsing of the detect response has been done so that we get the list of all the objects and list of the faces, and with the specifically timestamp so that we have that keyframes to be extracted. And here you see that get frame bytes and all the object frame to disk, and all the operation has been done to get that frame so that it can be displayed on the UI, specifically to get the hidden insights in a very interactive way. So lastly, we'll discuss about Nemo Retriever. Before that, let's have a look at the .env example, so that you know that what needs to be configured well. So you need to configure the NVIDIA API key, which you can get from the build.nvidia.com, and this is for the self pin, which you can turn off also. Here you need to have like the index ID name, here as S3 bucket name, AWS region, and all your AWS credential, and make sure that on IAM admin you have configured and provided the access of AWS Bedrock so that you can access the model via the AWS Bedrock. Okay, so now we will be having a look at the Nemo Retriever, or you can also have a look at the Nemo Retriever GitHub to understand about how NV ingest you can make use of it in a different way. And here are some of the configuration which has been done about the S3 bucket, about the S3 doc prefix, about the NVIDIA API key, which we will be loading from the environment variable, the embed model, which is llama nemotron embed VL, which we can see 1B. So you can see there are a lot many utilities here, from storing the PDF document to the S3 bucket, and then making use of that URL as a metadata for the embedding chunk so that we get the reference of the document. There are like lot many stuff as in extracting the document, and how does it work is there are like lot many other utility which when the PDF has been provided, getting the specific chunks and also specific section based chunks, and then the embedding has been created of that. Specifically, if we go towards that snippet, so here we see that embed via request, and here we see the request.post has integrate.api.nvidia.com v1 embeddings. Here the NVIDIA API key has been applied, and here the input as text has been provided. A model as embed model, which we have already configured, encoding format as float, input type as input type. So what does that mean is like whether it's a passage where we need the whole passage needed to be embedded and been stored, or whether we need just a text query which needed to be embedded for the searchability. And this helps us to provide the vector or the embedding. So and other utility function which you can explore, like adding the chunk or searching the docs here, and how does that work. So listing the chunk, ingesting the documentation of what I have discussed earlier, like which consists of all the other utility as storing the PDF document and split into semantic chunks. So yeah, so this was the complete walkthrough around the application and how easily you can build an application around it by making use of the TwelveLabs Marengo and Pegasus model via the AWS Bedrock, and also Nemotron Retriever for document retrieval, which makes your application multimodal in nature and actually gives you more personalization and more power for the searchability and analysis. Thank you.